that a partial temporary charge. Now I say we would call it that, really I would call that that. That's not like an official term or anything, but it makes sense to me, right? Ion is strongest because it has full charges, a full 1 plus or full 1 minus, all the time. Dipole is weaker than that because it only has partial charges all the time, and then induced dipole, or London dispersion is even weaker than that because it has partial charges but only some of the time. So there are some intermolecular forces. Now let's fill in these gaps, shall we? I did not leave enough space. All right. We can have two ions that are attracted to each other. We could have two polar things that are attracted to each other. So it's conceivable that we could also have thing 1 be an ion and thing 2 be polar. What do you think we would call that? We would call that an ion dipole intermolecular force. So an example of that, well, I can just use these. Zoom in. So let's say that I had my polar thing. Okay, sorry guys. This is Jeremy not thinking ahead. Okay. We could have a polar thing. For example, if we had a vat of HCl, hydrochloric acid, this Cl again has a minus, the H has a partial positive, okay, and I dumped some salt, some NaCl, into that HCl. Well, that salt might dissolve, and if it dissolves, I would be left with my Na and my Cl. Cl minus, Na plus. Well, hopefully you can recognize here that there are some opposite charges that would be attracted to each other. So each of those red dotted lines would represent an ion dipole intermolecular force, because there's, in this case, an ion and there's a dipole. And those separate molecules are attracted to each other because of those charges. Okay, I'm going to draw a line here to leave that gap, and then we'll jump down here. So, similarly, if we can have two polar things attracted to each other and two nonpolar things attracted to each other, it would make sense that you could have a force attracting a polar thing and a nonpolar thing. So if thing 1 is polar and thing 2 is not, and what do you think we'd call that? We would call that dipole induced dipole. Dipole induced dipole. Okay, so I can use this example right here. Sorry, I'm really OCD about these lines. Okay, so for example, if I had HCl, I'll draw those dipoles. And that HCl molecule came pretty close to my nonpolar pentane. Well, this pentane has electrons in it, and those electrons are going to see the charges on this HCl, and what are they going to do? If the Cl side of the HCl molecule is closest to the pentane, what are the electrons going to do? Well, negatives would repel each other, so the electrons would jump, they'd run away to the other side of the molecule. What's that going to create? It's going to create a partial negative and a partial positive, which leaves opportunity for an attraction there. So this is a polar molecule with its dipole and a nonpolar molecule with its induced dipole being attracted to each other. Because they're separate molecules and they're being attracted, we call that an intermolecular force. All right, and that leads us to this last one that I have here. You might be thinking, what about hydrogen bonds? Hydrogen bonds fall here. So hydrogen bonds are between two polar molecules, okay, but they're a special type of dipole-dipole. It's special because it's stronger than a normal dipole-dipole.